Hi, everybody. Welcome. I'm Leonard Barker from Ethan, Senior Cyber Risk Advisor from down in Melbourne, Australia. We might just give a couple more minutes for people to jump in before we get stuck into being able to talk about why it's time to move on from manual controls testing. So hopefully everybody's enjoyed all the talks so far. And I'm really excited to be able to share this with you. So yeah, thanks for having me. I might just get stuck into it now. So I wanted to start with a quick poll. Give me a thumbs up if you really, really enjoy doing security controls testing. Right, so I'm not seeing a huge number of thumbs up, which is kind of what I expected, right? Let's be honest, testing controls isn't exactly the highlight of most people's week in the security game. It can be considered tedious, time-consuming, and let's face it, not exactly what most of us signed up for when we got into security. So we still do acknowledge critical infrastructure, financial services to ensure that the systems that we oversee are secure. And while we know that it's critical, you know, we want to find the best way that we can go about solving that problem, right? So traditional methods of testing controls, they tend to rely on countless hours of educating and interviewing stakeholders, collecting evidence and preparing reports. We select samples at a specific point in time or even over a period of time. We often attempt to check our controls maybe once or twice a year for critical systems and then maybe not even for some other systems. But what happens if something changes between the times we test these systems? It goes unnoticed until the next controls test. So we continue to go through the motions, ticking our compliance boxes and crossing our fingers, hoping that nothing slips through the cracks, right? But deep down, we know that this approach isn't enough. We get a periodic, like snapshot, a single moment in time, and we know that the controls environment is going to keep changing. So what if there was a way to take the pain out of this controls testing approach? A way to shift from these periodic tests to something more continuous, and something maybe a little bit less of a headache. That's where automated controls assurance comes in. So imagine a world where you're not just checking a box once a year, but continuously monitoring your controls 24/7 with the help of technology. No more catching up, no more stress about missing some control failures. Instead, you have a system that works for you accurately, continuously, and efficiently. Today, I'm going to walk you through how the shift to automation isn't just possible, but it's actually necessary. By embracing this new approach, we can not only relieve ourselves of the burdensome task of manual testing, but also achieve a higher level of security that's truly fit for today's challenges. So when we set out to test our controls, the first thing we tend to do is determine what our scope is. We determine which controls we're going to test and which parts of the environment they cover. But here's the issue. We often end up testing just a fraction of that entire environment. It's like inspecting a handful of items from a massive warehouse and assuming the rest are fine. Once the scope is defined, we can then assess design effectiveness, whether the control is theoretically capable of mitigating the identified risks. But just because a control looks good on paper doesn't mean it will work in practice, which is why we also test for operating effectiveness, checking how well it works in real-world situations. So here's where it tends to get tricky. To test operating effectiveness, we often deal with a huge volume of instances where the control was applied, sometimes in the thousands. Testing every single one of these instances isn't feasible with the resources we have available to us, so we rely on sampling. Depending on the size of the sample, whether it's 10% of the instances or just a handful, we get a partial view of the control's performance. The big question remains, what about the instances we didn't test? If the control failed there, we wouldn't know. This leaves us with uncertainty, and we might conclude that the control is effective based on a small sample, but it's an educated guess at best. Traditional methods using limited samples and testing at a specific point in time leave too much room for error and don't provide the full picture. And remember, an attacker only needs to get in once. The solution: controls assurance automation, which allows us to test every instance of a control continuously and in real time. So within automation, instead of testing a small isolated sample of controls a few times a year, we can continuously test every instance in real time. This means no more reliance on random sampling or hoping that we've caught potential issues during a periodic check. Automation also provides 24/7 monitoring, ensuring that every control is checked every time it's applied. So gaps are closed and less slips through the cracks. But it's not about doing more, it's about doing it smarter. Automating controls testing reduces human error, it speeds up the process, and it eliminates the need for repetitive manual checks. We can gain real-time assurance that our controls are functioning as they should, and any issues are flagged immediately, allowing for instant responses. The real advantage: by removing the burden of manual testing, we free up valuable time and resources which can be redirected towards more strategic tasks, like strengthening security and addressing emerging risks. What used to be a reactive snapshot-based process can now become continuous and proactive. So I wanted to give you a little view of the sorts of controls that we might be able to automate the testing of. And to be really clear here, what we're talking about is not automating the controls themselves. We're talking about how we would go about testing them using automation. So I pulled up the new NIST framework here, and this is a good sort of coverage, and I'll give you this view of how we can automate the testing across this whole framework. So the govern function ensures that your cybersecurity activities align with business objectives by defining roles, responsibilities, and policies. It also helps manage risks like those found in supply chains by making sure that the right structures are in place. Traditionally, if we were testing whether a policy exists, we'd request a copy of the policy, check if it's properly documented, has the necessary approvals. We'd look how it's communicated. Did it go out via email? Was it on an internal website? After that, we'd validate that the right stakeholders actually understood their roles and responsibilities related to that policy. This might be through interviews, emails, or just people confirming they've read and understood it. So to automate how we might test that, we could make this process much more efficient by hosting policies in a centralized repository. We can assure that everyone that needs to be able to access these policies has access to the most up-to-date version. When a new policy is released or updated, it can be automatically shared with the right stakeholders, right? So using an attestation portal, stakeholders can confirm that they've read and understood their roles and responsibilities, and there's no need for manual follow-ups. Automation can help track who's acknowledged it and who hasn't, and we can get a good picture of the coverage through that control. So the next one is the identity function. Some of these controls get a little bit more technical here, which plays well into automation. So the identify function is about maintaining a clear and continuous understanding of your assets, risks, and vulnerabilities. It ensures you know what needs to be protected and helps you stay ahead of potential threats. Traditionally, to test identify controls, you might manually review your asset inventories. You'd request lists of hardware, software, and other assets and compare them with what's actually been used. We would cross-check for discrepancies. You might compare those manual lists with network logs or system usage data to identify gaps, like outdated software. And we might check where we're manually checking vulnerabilities. So to make that more efficient with automation, we might leverage asset inventories that are continuously validated through regular automated scans of hardware and software, ensuring that all assets are accounted for. So automation can flag discrepancies in real time, like if a new device connects to the network or software goes end of life. Even if you're working with manual inventories, automation can help you by cross-referencing those manual records with network logs and software usage, giving you more confidence that your manual processes are accurate. Network traffic can be automatically monitored and ensure it aligns with predefined communication flows. and you can flag anomalies that can be that may indicate unauthorized activity. We'd be checking that these sorts of activities would be occurring. So moving on to the protect function. Protect function ensures safeguards are in place to keep critical services running smoothly to protect data. This includes managing identities, access, ensuring data security, promoting cybersecurity awareness. So traditionally, for IAM systems, we may request a list of all accounts. We might validate that list against the predefined criteria for who should have access to what. We might want to identify things like dormant accounts that have been, whether they've been disabled or removed. We can review who has privileged access, right? We can confirm how someone authenticates, whether it's through multi-factor authentication for a particular system or not. Controls like data encryption, you might review manually the configuration policies for particular storage platforms and check that the correct algorithm is being used with the correct key size for the particular type of information that's being stored on that platform, whether it's appropriate or not. For training, similar to the policy activities, you may have this learning management system portal, and you can track coverage of your staff for each training activity through that sheet. Sorry, without using a spread, or you may previously have used a spreadsheet, but with automation, you might use a proper LMS with and be able to receive a integration with that, right? So for automating the identity controls, we can validate by cross-referencing a system's account list with predefined policies to ensure that only authorized users, devices, and services hold valid credentials. We can check for things like dormant accounts and authentication methods. Is MFA being enforced? Encryption validation is much easier with automation, right? We can just literally pull a security config file out of your cloud instance and check whether the appropriate algorithm is being used. We've already talked about the training compliance issues. So you can see here some of these more technical controls, they do lend themselves quite well to automation. So in this area here, sorry, that's supposed to say detect. In the detect domain, what we're looking at here is monitoring controls, right? So the goal is to ensure your network and systems are being continuously monitored for potential threats and anomalies. Traditionally, testing these controls involves manually checking logs, configuring and ensuring that alerts are being triggered when needed. Traditionally, this would look like manually reviewing those logs and validating the configuration settings. And then if you were to try and automate that, you might integrate with the SIEM. We can validate by checking whether the SIEM is capturing logs from relevant systems. If there's not enough coverage across all the systems, that may be a gap, right? When we could make sure that the SIEM is receiving threat intelligence feeds and correlating event data to set up alerting and incident notification correctly. So speaking of incident notification, the final two functions here, I've got respond and recover. I've rolled them into one here because these two are mostly focused around process-based controls. And full automation may be a little bit tricky with these sorts of controls, but the sorts of things that we can check for might be more along the lines of, did a certain activity happen, right? So to manually check these controls, we would be tracking whether the incident steps have occurred. We would have to verify what actions happened within each of the steps. For example, like containment and eradication. What did you do to contain and eradicate the incident? And then you'd have to manually check how evidence was logged. Was the chain of custody maintained? So automation is probably better suited to check that those activities have occurred here rather than what the specific things have been done within each of those steps, right? So as you can see across the NIST control functions, you've got pretty good coverage for testing using automation. And I think you can sort of also see that there are some domains that do lend themselves to requiring some kind of human input. That's why we're not saying that you need to replace humans with automation completely. You will always need an expert to be able to have sort of nuanced opinions and judgment for these sorts of controls. So let's look at where we're heading, right? Maybe we start with what we do know. The cloud is here to stay. It's the norm for most organizations, doesn't seem to be slowing down. So how do we ensure that we have continuous controls assurance in this cloud environment? Well, it's quite simple, and a tool like CyberSane actually supports this quite easily. You just create like a read-only account within your cloud environment that has access to security configurations or service configurations, and you can actually integrate that directly into your controls assessment, right? So it'll pull the configs out, and then you can choose whether it's effective or not based on your predefined policies. This is like a real game changer in comparison to the periodic audits that we used to rely on. Doesn't require much human judgment. It's just literally binary. Is it in compliance or not? And then as soon as it's not in compliance, you'll be notified. The next thing is there's a bunch of existing tech that we should be leveraging for to better understand our controls posture. So there are, again, within CyberSane, I've seen that there's some integrations for tools like Tenable and other vulnerability management platforms. These are fantastic because if you integrate with those, you can get a good picture of device health. You don't have to reinvent the wheel to understand security posture here. You just have to be able to integrate with some kind of existing tech to be able to get that information out of it, right? So the hot topic at the moment, I guess, is this rise of generative AI. There's some real potential here. One promising use case, I was just looking at a tool the other day that has like a generative AI front end. So it's kind of like a user interface where you interact with a bunch of expert bots, that are trained to have certain skeptical outlooks on how you might approach risk management or interrogating some kind of controls evidence. This sort of use case for generative AI seems like it's really positive for me. It can break down the complex information into plain language, making it easier for everyone to engage with. It could be a big win for bridging the gap between security teams and business leadership. I've also seen some tools using generative AI that do things like document processing. I don't know what your experience has been with generative AI for processing large amounts of text, but mine has generally been that there can be some quality issues with this. I'm not sure the tech is 100% there yet, but certainly as this tech evolves, this is an area that would free up a lot of time reading documents, making sure that policies are appropriate, etc. Right? The main thing at the end here is we need to make sure that we're prioritizing quality in assurance over convenience. So when we implement these automated tools, no matter how attractive it seems, no matter how convenient or time-saving it looks like it's going to be, I think priority should be the lens that we should be applying here. Sorry, quality should be the lens that we're applying here. Now, just for fairness, I think it's appropriate to include some of the key arguments against automating controls testing. I know that some of you might be thinking, is it really going to be delivering what we need? If you've been involved in automation projects before, you'll know they can be very tricky. Automation sounds great in theory, but in practice, it comes with its own set of challenges. Some of the common concerns I hear include that it can miss the human context. Not everything can be automated. There are decisions that require human judgment, especially when dealing with exceptions and on specific business contexts. An automated flag for non-compliance might not always tell the story. You can't automate what you don't understand. So automation only works when processes are well-defined and clear. If controls are poorly implemented or unclear, automating them just scales the problem. In other words, automation doesn't fix chaos, it just magnifies it. So false positives and over-reliance. We all know the risk of false positives, alerts for things that aren't really problems. It can lead to alert fatigue, the assumption that if the system isn't flagging anything, then it's fine. Automation should be supporting decision-making, not replacing it. And then the final point here is that maintenance is a really key component of this automation for controls testing. It's not going to be set and forget. It's going to require ongoing maintenance. Security configurations evolve, new threats emerge, new systems come onto the environment, systems go end of life, the environment changes, right? So without this upkeep, automation can quickly become outdated and unreliable. These concerns are valid, and they remind us that automation isn't a magic fix. We need to be strategic about how we implement it, using it to augment our processes, not blindly replace human oversight. The key is to strike a balance between machine efficiency and human insight. So automation doesn't have to be an all or nothing approach. We can be practical and strategic. And here's some of the tips that might help when first implementing an automated controls assurance program. So start small and scale smart. Begin by automating straightforward tasks. Think policy attestations, routine vulnerability scan, identity access management, and device configurations, things like that. You've already got that data. It doesn't require a lot of human judgment. So once you've got those running smoothly, gradually expand into more complex areas. It's not crucial to rush. Let success and feedback guide the scaling efforts. Keep the human element. Automation should support and not replace human decision-making. There'll be scenarios where human judgment and context are vital. Ensure that your automation strategy leaves space for human oversight, especially in critical decision points or gray areas where exceptions might occur. Commit to continuous improvement. Automation isn't a set and forget solution. You might need a process for regular review and refinement. As your systems evolve, so should your automated workflows. Prioritize maintenance and monitoring. Just like any system, automation needs regular care. And finally, measure and adapt. Success in automation is measurable. Define clear metrics from the start, whether it's reducing false positives, cutting down on manual work, improving report accuracy. Regular review of these metrics and adjust your strategy to continue. So regularly review these metrics and adjust your strategy to continuously optimize performance. So where does this leave us? Cybersecurity is evolving rapidly, and we can't afford to rely on outdated manual processes. Automating controls assurance isn't just about making our work easier. It's about ensuring our controls are doing their job. We need the confidence that our controls protect our critical information, not only to safeguard our assets, but also to meet regulatory and compliance requirements. Instead of periodic snapshots, automation gives us continuous real-time visibility into our security posture. It allows us to detect issues early, respond faster, and ensure compliance without the heavy burden of manual testing. Challenges still remain. Automation doesn't fix everything overnight. But by starting small, maintaining human oversight in key areas, and focusing on continuous improvement, we can develop automation strategies that truly enhance our assurance efforts. Ultimately, automation lets us focus on what matters most: managing risk, improving security, and staying ahead of the threats. The tools are ready, the technology's here, and now it's up to us to use them to protect our information and meet our compliance requirements. Let's take the next step and embrace the future of controls assurance, one step at a time. Thank you very much. We have a few minutes left. If there's any questions, feel free to pop your hand up and ask them now. If we haven't got any questions, I think I'm happy to wrap it up and hand you back a few minutes in your day. Okay, great. So thanks for having me. Thanks to Cyber Saint and Cyber Strong for having us here, and yeah, enjoy the rest of the conference.